Here we're looking at 4b from the 1.3 set of notes. We have the limit as x approaches 2 of this fraction over this other fraction. So a lot of fractions going on, and unfortunately if you tried using that direct evaluation, you would end up with that 0 over 0 indeterminate form. So that's no good. That's not going to be able to help us. Then we have to do something else. One alternative that we can do, and we've seen factoring in the past. Unfortunately, that's not going to quite work here either because there's not really anything to factor with. So another option, though, that we can do and that we're going to discuss right now is going ahead and doing a little bit of foo to get these to have the exact same bottom such that we can combine this entire top. Because right now, they're in two different fractions, and that's making our lives a little bit harder. So we actually need to go ahead and combine the top into just one fraction. So we're going to do a little bit of foo. We're going to multiply this guy by x over x, and this one by 2 over 2, such then that they end up with that same bottom, 2x. So when we do that, we end up with the limit as x approaches 2 of 2 over 2x minus 1 times x will just give us x, and then this guy is also over 2x. So then this is all over that x minus 2. And as a result, we can now go ahead and combine this top into just one fraction. So we end up then with the limit as x approaches 2 of 2 minus x over 2x all over x minus 2. Now, subtly, this x minus 2 is actually considered to be a fraction. Really, it's x minus 2 over 1. And so right now, we have a fraction over another fraction. Now, just a little side example. If I gave something like, we'll go with 1/2 divided by 4. Again, that 4 is over 1, really. And so really what we can do is go ahead and rewrite this as 1/2. Instead of that division bar, we place it with a division symbol. These two are in fact equivalent with one another. And then what we would do is we would flip the second guy and then change that to a multiplication. So we're going to go ahead and just kind of do the exact same thing with ours, with our rational functions. So then we end up with the limit as x approaches 2 of 2 minus x over 2x. I'm going to go ahead and just change that division bar into a division symbol. And then we have x minus 2 over 1. And just like we did over here, we're going to go ahead and flip this second piece. And then change that to a multiplication. So then when we do that, we end up with the limit as x approaches 2 of 2 minus x over 2x multiplied now, because again we're changing that sign, by 1 over that x minus 2. So again, we flip the second piece. Anytime you are dividing by a fraction, ultimately you're multiplying it by the reciprocal. We've heard that many times in the past. And now we can go ahead and see if anything cancels. Well, unfortunately, it doesn't look like anything's quite canceling right now. So, one option though that we can do is go ahead and maybe factor out, let's say like a negative. So if we factor out a negative out of this piece, we end up then with negative of negative x plus 2. And now, if I go ahead and just swap the order of these, we end up with the limit as x approaches 2 of 2 minus x over 2x times 1 over, that negative is still there, so we have negative, and I'm just going to go ahead and flip-flop the order of these two. So we end up with 2 minus x. Now, they both share that common 2 minus x. And those can end up just canceling out with one another. So there's a little bit of strategy as you're doing these, that maybe you need to factor out like a negative. Again, it's really subtle. Typically we don't do that in math, but in order to get something to cancel like this, maybe sometimes you do have to pull that negative out. And as a result, we then end up with the limit as x approaches 2. Really, there's just 1 on top over, we have a 2x times negative 1, so that'll be just negative 2x. And now we shouldn't end up with that 0 on the bottom. So now we should be able to just go ahead and use that direct evaluation. So we end up with, oops, then we just go ahead and throw that value in there. So we have 1 over negative 2 times 2 to give us then that limit of negative 1/4. So again, that is problem 4b from our 1.3 set of notes.